Hey guys, this is just going to be a quick video wrapping up transforming functions and what we learned about yesterday and what you learned from the activity that you did in Desmos. So you need to find that sheet that I gave you yesterday, that sheet of paper. So please find that. If you were gone yesterday, I think there's one copy on my desk you can get from the sub. Otherwise, if you don't have it, you can just write this in your notebook. All right, as a quick little warm-up, do you think you could write a rule if I was asking you to transform the parent graph of a parabola? Could you write a rule that says that you're going to slide it right 2 and up 2? And then could you write a rule that was doing all 3 of these things? A vertical stretch of 3, slide it up 4, and left 3. Do you think you could write 2 rules for these? So pause and try to write those. All right, so the first one, hopefully you said, if I want it to go right 2, we learned yesterday, you're going to do x minus 2 in parentheses squared. And then if you want to move it up 2, it's that plus 2. Okay, and then a vertical stretch of 3. So we learned yesterday that I'm going to multiply the x squared by 3. But if I'm going to slide it left 3, I need the x plus 3 here squared. And then if I'm going to slide it up 4, it's up 4. Now, here's the next thing that I would like you to do. You're going to need to pause, get these 2 equations. You're going to go into Desmos, and I want you to graph both of those. First, I would graph the parent graph. So on your first line, do your parent graph, y equals x squared. Then on your second line, graph this one. Okay, and then I want you to figure out, well, what is the vertex when you graph that one? And then the second one, could you also tell me what is the vertex? So go ahead, pause the video, go to Desmos and do that. And then write down your 2 answers. All right, so if you graphed both of these, you can see my vertex in my new one is right here. And the coordinates for that one are 2, 2. Okay, and then my vertex in the second one that you did, it looks like my vertex is -3, 4. Now, here's what I want you to think of next. When you did that, do you notice anything in the equations, here's my 2 equations, that might help me get to the vertex? Okay, and same thing here, that might help me get to the vertex. Do you notice anything about them? Okay, look at the numbers. What do you notice? All right, so hopefully here is what you maybe have noticed. The second number, that 4 and the 2, comes from back here. Okay, so that's the y-coordinate of my vertex. That would make sense because I slid it up 2 and up 4. So if it was at 0, 0 and I slid it up, that would kind of make sense that it should now be at 2 and 4. The other number, if I slid it, this means I slid it right 2. That would make sense that my vertex is a positive 2. And here I slid it left 3, so that would make sense that my vertex x-coordinate is a -3. So when you have a vertex, it's actually the opposite of whatever's in the parentheses. Okay, so like this is -3, and this was a -2, so I made this a positive 2. There is my vertex. So hopefully that's kind of something cool. So if I gave you this one, y equals x plus 5 squared minus 10, could you find me the vertex from there? Well, first of all, I would say, hey, this is a slide left 5, or a translation left 5, and this goes down 10. All right, so my vertex, it's going to be down 10, so I'm going to do my y-coordinates -10, comes from here. And here I really move left 5, so it's going to be at -5, -10. So it's always the opposite of there, and exactly what that one is. So there is the vertex. All right, so we just actually learned another form of an equation for a quadratic. So you're going to want to put this in your notebook. This is called the vertex form of a quadratic. So basically, when I have an equation written in this form, like this, I can easily find the vertex. That's why it's called vertex form. Now, we already know standard form. We know standard form looks like this, ax squared plus bx plus c. We learned that already. That can be helpful to find the y-intercept, because I can quickly be like, hey, there's the y-intercept. I could also factor it to find the x-intercepts. I can find the axis of symmetry, -b over 2a, so I can kind of use standard form for a lot of things. But this is called vertex form, and it's super helpful in finding the vertex. So again, if it's written like this, here's kind of what you know. Here's the letters that they use. They use H and K, so the vertex is H comma K in this case. So this gives you the Y coordinate of the vertex. This number gives you the vertex, or the X coordinate of the vertex. Now they always write it as negative H. So for example, if I had Y equals X plus 3 squared plus 7, I would know that my vertex has a 7 here. And then I could rewrite this as X minus negative 3. So it kind of matches up with this X minus here. And then I could say, oh, my vertex is negative 3. I just like to think of it, whatever you have here, it's just the opposite of it. So negative 3 comma 7. So this is vertex form. No idea where the letters H and K came from, where they came up with that from. But you're going to be seeing those today. All right, so now we are going to fill out this transformation guide. You may use this on a test. So we're going to fill this out. You can go ahead, fill it out ahead of me, or you can kind of fill it out with me. So parent graph is y equals x squared. We can quickly just graph that parent graph. So the parent graph always starts at 0, 0. If I square 1, it's 1. If I square 2, it's 4. And then obviously there's a line of symmetry, so I'm going to sketch that in. The vertex of a parent graph the coordinates are 0, 0. All right, the next one we learned about yesterday is called a vertical stretch. Well, here's what the equation would look like. Y equals, if I stretch it, you just put a 4 in front of there, x squared. So again, they have the parent graph already graphed for you, kind of dashed line. Now, if I want to graph what this looks like now, you could either use decimals, or I'm just going to do like I'll just do a couple points here. So if I plug in a 1, I would do 1 squared is 1 times 4 is 4. So I'm going to do 1 comma 4. So negative 1 is going to be the same thing. If I plug in a 0, it's still 0. So here's what that graph would look like. That's a vertical stretch. All right, so has the vertex moved? Nope, it's still 0, 0. And if you wanted to write this in vertex form, it'd be like this. Y equals 4. It's really like an x minus 0 squared plus 0. So I can still write it in vertex form to get those coordinates of 0, 0. All right, the next one is a vertical compression. It's saying that the a value is a half. So that means I'm going to put that 1/2 out in front of the x squared. All right, so same thing if I plug in, I like to just kind of plug in a point over here. If I plug in 1, so I would do 1 squared first, which is 1 times a half is a half. So that means I'm going to go over 1, up a half. I'll do that over here too. If I do a negative 1, I'll plug in a 2. So if I do 2 squared, that's 4, times a half is 2. So my next point is going to be 2, 2, and negative 2, 2. Maybe I'll just plug in a 4 real quick. So 4 squared is 16, half of that is 8. So it'd be 4, 8, which I can't even fit on my graph. But you guys can see that, and 0, 0 still, it's going to kind of look like this. So it looks like it got wider. And remember yesterday I talked about a vertical compression. It's like if I had my hands up and then I'm like squeezing them down, it's going to widen it. So you might even want to put this as a note. It kind of widens it. The vertex has not moved. It's still 0, 0. All right, the next one, number 4, is a reflection. All right, the equation for a reflection we learned yesterday is that you just put a negative sign out in front of it. Okay, the vertex is not going to move, so it's still going to be 0, 0 on this. If I reflect it, you guys can kind of figure that out. So if I have the point 1, 1, it's going to come down here, reflect across the x-axis. Then if I have 2, it'll come down to 4. Okay, so basically all it does is flips. All right, and my vertex is still 0, 0. If you want to make yourself a note, it's going to flip over the x-axis. All right, so my next one, now this is a translation up. So we learned yesterday that the rule looks like this. You still have that x squared. Then if you slide it up, it's that plus 2 in the end. Okay, now this time the vertex is going to move. It's going to go up 2. If you wrote this in vertex form, it would look like this. So I still could put my x minus 0 squared plus 2. So I'm going to see that my vertex is 0, 2. Okay, do you see how I'm just kind of rewriting this in that vertex form? Because remember, vertex form looks like this down here. So I'm just kind of rewriting it to get there. All right, so now if I'm going to just slide this up, it's going to look like this. And then it's going to just kind of go up from here. If you wanted to get some points, you could, but it's going to stay the same width and everything. It just slides up. All right, let's go to the back. All right, a translation down. That's where you have that x squared and you just minus 3 in the back. Well, the vertex is clearly going to move. Now it's going to be at 0, negative 3. So all I'm doing is sliding it down. It's still going to be the same width. Again, I could actually get some real points. You know, if I plugged in like a 1, I would do 1 squared, which is 1, take away 3 is negative 2. So 1, negative 2, which mine landed pretty good. But you could always just plug some points in. Again, if you wrote this in vertex form, it would look like this. Y equals x minus 0 squared minus 3. And then I can see, hey, my vertex is 0, negative 3. All right, if we translate right, your rule looks like this. Y equals x. Okay, if I go right, it's like this, minus 2 squared. All right, now the vertex definitely has moved. It moved to the right. Okay, so here's my original vertex. It's going to move to the right 2 spots, and then it's still going to go up in the same shape. And the vertex is now going to be 2, 0. I went 2 to the right. All right, so my next one says I'm going to translate left. Well, we know the rule looks like this. Y equals x plus 1 squared. Now, they wrote that h was negative 1 because if I just kind of rewrite this, I could say y equals x minus, because that symbol is always really minus in the graphing form, negative 1 squared. Now this looks like the exact same thing. So the vertex clearly has moved. It is going to go to the left a spot, okay, and then I'm not drawing this perfect, but it's going to stay the same shape. So now my vertex is negative 1, 0. All right, then the last ones, I want you to go ahead and do those two. Down at the bottom, you are going to see the vertex form for parabola. All right, so if you tried these, hopefully you have y equals for this first one. If I went right 2, I'm going to say x minus 2 squared, and then it went, this should have said up 1, so this should have been a positive 1, so plus 1. Okay, the vertex has moved. You can see that the vertex is going to be 2, 1. And then the last one, it was a vertical stretch, so I'm going to put my 3. And then it says I'm going to go left. So to go left, I'm going to put x minus 1 squared, and then down 4, minus 4. There's your rule. My vertex is negative 1. Oh, positive 1, sorry, negative 4. All right, now I want you guys to try the homework problems in Schoology. Try as many as you can. I'm not going to assign. Just use your class time to get as many done as you can, just to have some practice. As long as you guys are working the entire time, you won't have to finish these, but just go ahead and pick some of them to try.